Hello everyone, welcome back. So today we will be solving our second problem, which is valid anagrams. Okay, let's see. Given two strings S and T, return true if the two strings are anagrams of each other, otherwise return false. An anagram is a string that contains the exact same characters as another string, but the order of characters can be different. Okay, let's take this example. So I'll explain what anagram is. So anagram is a word that is formed by rearranging the letters of another words using exact characters. Okay. Suppose we have here dad. We can also rearrange and form the word add. Also we have listen. We can rearrange listen and form silent. These are valid anagrams. Okay, valid anagrams. And these are invalid anagrams. Those are, I just copy pasted jar and jam. As you can see here, jar, we have jar, but here we have M instead of R, so this is invalid. Okay, first we are gonna solve it, then I'll explain how we are solving it. So as you can see the constraint, we are using the S and T consists of only lower English letters. So we can easily use integer hashing, integer array hashing. So integer HashMap equal to integer 26, because we have 26 letters in English alphabet. For each INS HashMap of I minus a plus plus. For each where I int HashMap I minus a minus minus. For each where I in HashMap, if I not equal to 0, return false, else return true. Okay, it's working. Nice. So now I will explain this code here. Okay. First I am initializing zeros from 0 to 25 here, because array index starts from 0 to 25, so totally 26 letters. So now I'll iterate over add. Okay, suppose add. Okay, first we'll have d minus c. We're doing this because if you minus character by character, we'll get an ASCII value. So ASCII value of this one is 97, and for this one is around 100, I guess. 8, 99, 100, yeah, 100. So we will get like 3. So in the array 0, 0, 0, 0, 0, and it goes on. So this is 0, index 1, 2, 3, A, B, C, D. Here we'll remove this and we'll add it 1, because we are increasing the value. Okay, D is done, first iteration. Next is A minus A. So this is 97 minus 97 equal to 0. So instead of here 0, we'll add it 1. Okay, now next comes another D. This D is done, the A is done, another D. So again D minus A, 100 minus 97, which is equal to 3. So again in T3's place we'll update. Why are we doing here minus A? Because minus A is the starting of the lower digit alphabet, so we can get the proper indexing. If you don't want to do minus A here, you can directly start, like make the array very big, like 127, and directly put the integer there, like array of d, like this. But you have to convert it to integer because we need the ASCII value. So the ASCII value of d is 100. So 100 can easily fit in 127. Okay, this part is done now. Now coming to next part, which is of this one, add. So add. Again I'll iterate a. We have a minus a with equal to 0. But here if you observe, instead of adding it, we are subtracting it. So this one will become 0. It's like neutralizing it. You will add from the one array and you will neutralize it from the other set of strings. So next one is d minus d equal to d minus a. D minus a, 100 minus 97 equal to 3. Again here 2 will become 1. Then again d minus a, 100 minus 97 equal to 3. Again this will become 1. So now this step is also completed. Now this is the final step. We will iterate over this HashMap arrays and we'll check if any numbers is not 0. If it's not 0, then it's not a valid anagrams because there is an extra character, or there might be in another mismatched characters that might be present in the strings. So hence we are returning false there itself. Otherwise the entire array consists of 0, we can return true. Okay, so now we'll show another invalid example. Example is jar. Okay, jar, and this is our array 0 0 0 0 dot dot dot, because let me consider this a and dot dot dot. So we can consider this as a B C D J somewhere over here, dot 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 r, because I can't draw the entire 26 digit here. I mean I can draw, but it will consume time and simply waste of time. So now again j minus a, looping over this j minus a. So j is ASCII value. Let me check. ASCII value of j 106. So 106 minus 97, that will be around 9. So 9, at the 9th index you will add 1, that is here 1. Okay, next is a minus a equal to 0. So here you will add 1. Next is r. ASCII value of r 114. So r minus a equal to 114 minus 97. That would be 14, 17. So at the 17th index you will add 1. So this is jar. Okay, now we have jam, the another set of string. So again j minus a equal to 9, which is this one. So this one j, we will neutralize it 0. Now we have a minus a equal to 0, which we know, and again this one we will neutralize it. Now we have m minus a. What is ASCII value of m? 109 minus 97, that would be around 16. So the 16th index, okay, m and r, not 16, wait, 12th index you will add this 12 or 13. Okay, I think it's 12. Okay, 12th index somewhere you will come m. This is r. M, you will add 1. Okay, now even this step is also done. Now coming to this part. So we will loop over this array 0 0. Okay, fine. But in J, okay, j is also 0, but in mth index we'll have 1, which is a mismatch because we're having a r here and we're having a m here, which is a mismatch here. So hence we'll return false. False. That's it. That's the solution. And also there is one more approach, but I don't think this is the best approach. We can solve this using sorting. Suppose we have dad, add. You can sort this one, it will give add, and even you can sort this one, it will give add. If both are equal, it is a valid anagram. If not, it is invalid anagram. That's it. So that's all for this valid anagram. If you have any doubt or if you need any video on any other languages, let me know. Thank you.